Hey guys, welcome back. Today we are going to do inverse relations and functions. So let's begin. Inverse relations and functions. Inverse the opposite. For question 1, which of the following is true for the relation fx equals 5x plus 1? Which one is true? So the first one, only the inverse is a function, neither the equation nor its inverse is a function, both the equation and its inverse are functions, only the equation is a function. So first let's look at the function. As you can see, the function is fx equals 5x plus 1. Of course, this is the function. It's a function y because to every value x, there is only one value, which is y. To every value x, there's only one value, which is y. For example, if you have this graph, okay? As you can see, to every value x, there's only one value y. It doesn't intercept the graph more than once. But if we have a graph, for example, like this one, okay? Now, if you go to the value x, this one doesn't matter what is the value. If you draw a line, it will cut the graph in two different places, and that makes it not a function. So in this case, it is a function, okay? It is a function. So if you put for x, either it's a positive number or a negative number or a fraction or 0, each time it's going to give you a different y or a different fx is the same thing. Now the question is, what about the inverse? So let's try and solve the inverse, okay? We need to find first the inverse function. How do you find the inverse function? Two steps. The first step, you need to isolate x. So we have the function fx, okay, equals 5x plus 1. We need to isolate x, so we subtract 1 from both sides. So fx minus 1 equals 5x. And now we need to divide both sides by 5. So f of x minus 1 divided by 5 equals x, because the 5 cancels out with the 5. Now the second step, you switch between x and fx. So fx will become only x, minus 1 equals 5, equals x will become fx. You add the notation negative 1, so we would know that this is the inverse of fx. Negative 1 means the inverse of fx. So this is the inverse, x minus 1 divided by 5. Now in this case, it's the same, it's a function. Why? Again, if you plug in positive, negative, or a fraction, it's going to give you a different y each time, so it is a function. So we just write down both the equation and its inverse are functions. That's the answer. Okay? Let's go to the next one. Hopefully we'll have an example where it's not a function. The graph of relation R is shown. So this is the graph of relation R, if you can see it. Okay? This is the graph. Which of the following graphs represents the relation and its inverse? So which one is the inverse of the blue graph? This one, this one. Of course, guys, the inverse. What is the inverse? The inverse, so you can make sure that you understand what is the inverse. The inverse is that if we have the point of x, y on the graph of blue, the inverse will have yx. Okay? So in this case, let's say this one is this graph, okay? Let's say it's 1, 2. Just for example, I'm not saying it's 1, 2, but for example, 1, 2. So the 2, 1 should be on the graph. So 2, we go 2x2 will be 2 here. Okay? And 1, and this one is 1, 2. We said this one is 1, 2. So 2, 1 is going to be here. Okay? and you continue. Okay, so this one, for example, we have 0, let's say 1. Okay, I'm sorry, it's going to be 1, 0. So it's going to be the same thing, 1, 0, so it's going to be 0, 1. So 0, 1, it's going to be where? Here. Okay, 0, 1, it's going to be here. So which graph starts on the y-axis? If we check, this one starts on the y-axis, this would be the answer. This would be the answer. We'll take another example when we get it. Which is the inverse of the function? Oh, we need to find the inverse, which is easy. Okay, we just solved one. We have f(x) equals x squared minus 4. Before we find the inverse, I just want to tell you, for example, this one is also a function. Why it's a function? Because every value x has a different y. Okay, a different y. So for example, look at this one. If we plug in the -2, it's gonna be -2. I'm talking about, let's take 2. 2 squared, 4. 4 minus 4 is gonna be 0. Okay, that's the y, so it's gonna be 0, 2. And it's gonna be also 0, -2. Okay, same thing, let's say for example 3. 3 squared is 9. 9 minus 4, it's 5. So 3 and 5 is gonna be somewhere here. Okay, and if you plug in -3, it's gonna be also 5 here. So the graph is gonna be somewhere like that, let's say. Okay, something, it doesn't have to be accurate, but as you can see, for the x-axis, it only cuts the graph only once. Now let's find the inverse. The inverse, we said we need to isolate x, so we add 4 to both sides. So f(x) plus 4 equals x squared. And we need to cancel the squared, so put it under the radical, or the square root of f(x) plus 4 equals the radical x squared. Now, the square root of f(x) plus 4 equals x. Now, of course, the second step, if you remember, we switch between x and fx. So it's going to be the square root of x plus 4 equals fx, and of course, to the power of -1, which means the inverse. The inverse of fx is the square root of x plus 4, of course, positive, negative, and the answer would be the first one. Okay? Now, I hope we'll see one that it's not a function. This question is, look at the function fx, the same thing. We have fx equals -x plus 5. Which of the following describes the domain and range of the function? Domain and range, it means which values I can plug in for x. So for example, the domain is which values I can plug in for x. Can I plug any number I want? Well, you can plug in positives. There's no objection. You can plug in negatives, a 0. You can do all of that. So for the function, for the domain, okay, for x, you can plug all numbers. Okay, for the domain, all numbers. Okay. For the range, also the same thing. You can plug any number you want. It will be added to 5 or subtracted from the 5. Any number you choose, right? So also all numbers. Now we need to find the inverse. The inverse, we need to isolate x. So we subtract 5 from both sides. So fx minus 5 equals -x. And divide by -1 or multiply by -1 and switch between fx and x. So it's going to be -x plus 5, okay, equals fx, of course, the inverse of fx. And of course, as you can see, it's almost the same thing. It's also, you can plug in any number here you want. And in this case, the y also, you can do the same thing. Any number can be subtracted or added to 5, okay? Any number you choose, you can add 5 to it or subtract from 5 from it. If it's fraction, anything you want. So both of them are all numbers. So the domain, all the numbers, all real numbers. Values, now this one, values for relation G are given in the table. So this is relation G. This is relation G, okay? Which ordered pair would be found in the inverse of G, okay? So this is G. So G is 2, 2. These are the points, 3, 5, 4, 9, and 5, 13. So in the inverse, it's going to be the opposite. So it's going to be the opposite of 2, 2 is 2, 2. The opposite of 3, 5 is going to be 5, 3. The opposite of 4, 9 is going to be 9, 4. The opposite of 5, 13 is going to be 13, 5. So any of these points will be on the inverse of G when you switch between the x and the y. So the only one that's here, let me see. So it's 13, 5. It's 13, 5. It's here. So that's the answer. 13, 5. So this would be the answer. Question 7. The same one as we solved. So I'm not going to solve this one. You need to solve it. I'm not going to tell you which one is the answer. Question 8. Which is the inverse of the function? We can solve this one again. So he wants the function f(x) equals 4x squared. We need to find that inverse. Again, guys, we need to isolate x, so we divide 4 by 4 both sides. So it's going to be f(x) divided by 4 equals x squared. We need to cancel the squared. We square root both sides. And then we switch between x and fx. So it's going to be x divided by 4, the square root. It cancels out. I'm left with the fx and with the negative 1, which is the inverse. So it's square root of x divided by 4. Of course, we add the positive and the negative. And yeah, that's it. Which one is the answer? It's this one. Why? Because the square root of 4 is 2. Now,